Okay, it is time to start learning some logs. The first thing we're going to learn is the most fun, and it's the log circle. So you can change from log form to exponent form if you know how to do this log circle. Okay, logs and exponents are inverses of each other. The first thing we need to do is take a look at this. Okay, that little a down there, that's the base. That's the base. And so what you do is you start here and you go in a circle up to there. Okay, and what you say is the words to the power of. To the power of. So if that's your base A, and you say the words to the power of y, okay, and then you finish the circle here and you say equals, so we'll say equals x. So we just switched from log form to exponent form. And for both the log form and the exponent form, the bases, the base and the base, they're both A. So now let me tell you how to talk. I know that you can read exponents and say a to the power of y. But how do you say this? You need to say log base A of x equals y. That's how you say it. And then when you do the log circle, a to the power of y, that makes it be an exponent form. Okay, here's a couple of important rules. You cannot take the logs of negatives, okay, or 0. So you want to make sure you check your answers. If you take your calculator and try to do some log calculations, the log of -5, oh, that's imaginary. Does not like that. Let me check my mode. Oh, let's switch to real mode. I only want to see the real answers because we're not going to do imaginaries. So log of -5, that's not real. Okay, we'll quit. And how about log of 0? Nope, can't do that either. It's having a domain issue. So you only deal with real numbers, and you cannot put negatives or 0 into logs. All right, let's practice writing these in exponent form. So we're going to do the log circle. Let's start with the base. Log base 3 of x. You can't say log of 3 of x. There's too many ofs. 3 to the power of y equals x. Okay, good job. Your first log circle. Let's practice it again. I like to have the y over here on the right-hand side. That way I can do my circle to the right. It's kind of weird going to the left. So I'll just write the y over there, and we start with the base. And we'll say 5 to the power of y equals x. There you go, exponent form. Let's try it again. 3 to the power of 4 equals 81. Is that true? 3 to the 4th power? That is true. So when you take a log and you calculate it, what you do is you're finding the exponent. That would make an 81. Let's do the same thing. Let's write the -1 on the right so I could do a nice circle. The base is 5. And so what we'll do is we'll say 5 to the power of -1 equals 1/5. Is that true? Do you have a negative power and move them downstairs? Absolutely. Okay, now it's time to practice writing a log. So what you need to do first is maybe get all these started. Okay, so what we'll do is I'll write a log, and I'll write some equal signs. Now, the base is 1.2. That base has to go here. 1.2, that's the little base. Now I'm going to do a log circle, and the log circle starts here and usually goes 1.2 to the power of 3. The 3 is going to go here, and if I finished my log circle, equals m. M has to go there. All right, now let me talk to all the ugly writers. No, I don't know who you are. What we're going to do is draw a little line right here. Okay, log, the letter M, the 3, that's all on that line. 1.2 needs to be real tiny and needs to be lower. You need to make sure that you write stuff low, middle, and high the correct way. All right, let's try the next one. We're going to write log and an equal sign. So the base is E. We'll start right here, E, and then the log circle says to the power of B equals, what goes here? 9. Log base E of 9 equals b. Log base e of 9. Okay, base is the same as the base. All right, let's do a couple more. I'm going to write the log and the equal sign, the log and the equal sign. All right, let's start with the base. The base is a to the power of 4 equals 24. So let's practice saying this log the right way. Log base a of 24 equals 4. That's the way you say it. Okay, let's go over here. The base is 2. The log circle would say 2 to the power of, what goes here, x. And then here on the of spot, 10. Log base 2 of 10 equals x. The better you get at log circle, the easier this entire chapter is going to be, because we're going to switch from log to exponents the entire time, and that's how we're going to do it. Let's talk about some special logs here for a second. One of the very most special logs, they use it a lot, it's very common, it's called the common log. Okay, the common log has base 10. So if you ever see log of x with no base, that means it's a 10. The 10 would go right there in that spot. It's so common that we don't write it, though. It's kind of like when you see square root of x. Do you know what the index is? Well, it's a 2. This is the square root. Everyone knows it. We don't write it because it's the most common. But if I want to say cubed root or fourth root, then I start to write the index. But we don't write the 2. We don't write the 10. That's called common. Another one is called the natural log. The natural log is because this is found in nature a lot. They did lots of studies. The same number kept appearing, the number e. And so what this is the natural log of x. They even switch log to ln, natural log. Think in Latin it's reversed. So if you don't see a base there, it's automatically an e. Which makes me want to go back to these examples we did over here. We're not going to write it like this. This looks so silly now that we know. If the base is e, you don't write that. Cross that off. You're going to write natural log of 9 equals a b. And everybody knows that the base is e. Okay, now that we know, we shouldn't have written that. All right, let's write some in exponent form. Let's do some log circles. All right, ready? We're going to start with the base. A to the power of 5 equals 4. Maybe we'll start to do it without writing those arrows. Here I don't see a base. Do you know what the base is going to be? That's right, it's an e. Maybe when you're first starting, you want to write the e just as you see it. So you could do your log circle the right way. E to the power of -3 equals b. How do you say that problem? Natural log of b equals -3. The of goes right there. All right, let's do a couple of more. Log circle, 3 to the power of c equals 5. I don't see a base. I don't see one. It's very common. That is an invisible 10. If you want to write it so you can help yourself do the log, that's fine. 10 to the power of 2 equals x. So I guess x must be 100. Okay? Let's practice with our calculator a little bit. I know I pushed this button earlier, but I didn't show you where to find the log buttons. So there is one log button here on the side, and it's the common log. L-O-G, that's the common log, no base. And underneath it is the natural log button. Both of those are right there. So the first thing I'm going to do, I already made sure my mode was reals. You want to make sure that yours is too. Okay, we'll quit out of there. And I'm going to type the log of 7. Close it up. The of right there is 7, and we're going to evaluate. So this is going to be an irrational number. So we're going to have to round this to a couple of places. I always prefer 2, so I'm going to write 0.85. And now it's time to try a natural log problem. The natural log of 9, go ahead and try pushing the buttons. Now we're doing a natural log, and the answer is approximately 2.20. Good job with the rounding. Okay, the only two buttons on our calculator are the common log and the natural log. We don't have any other log button. which leads me to wonder, how in the world are we going to do problems that are like this, where the base is not a 10 or an e? Okay, and here is one of the log rules. Log rule number 9 is the change of base. Very popular, especially with calculator people. The change of base says if you have a base that's a, and you don't like that base, you can change it if you divide two logs. So what we'll do is do the log divided by the log. Maybe I'll change to the common log since I have that calculator button. Log of something. I need to put something here. And then I need to put something down here. Which one looks like it needs to go up? Yeah, the m. So it's log of m divided by log of a. And that would be a common log. So I'm not going to write the tens. But I don't have to change to common log. I can change to natural log divided by natural log as long as they're the same. I would have to do natural log of m divided by natural log of a. Okay? Or maybe I'm in the mood to do log base 7 of m divided by log base 7 of a. I don't know why I would change to base 7s because I certainly don't have that one in my calculator either. So which ones are helpful if you're trying to use your calculator? You'd want to use one of these, either the common or the natural. Make sure you study those names. I'm going to ask you tomorrow if you learned about the two special ones and what they're called. So let's try doing some calculations now. Now that I know the change of base, 3 decimal places, I'm going to have to change this to 2 logs. Maybe I'll do the common log. Log divided by log. Log of what on top? That's going to be a 7 divided by log of 2. So I take out my calculator, and you have to be careful with your parentheses here. Log of 7, close it up. Then you hit divide. Then you do another log of 2, close it up. Make sure you close up those ofs. And this is about 2.807. 2.807. I'm wondering what would have happened if I did the natural log instead. Would I have gotten a different answer? Let's go see. If I had decided to change to natural log of 7 divided by natural log of 2, does that change things or is it identical? Oh, it's exactly the same, so it doesn't matter which one you change it to, you're going to get the same answer. Alright, I want you to go ahead and try log base 5 of 89, choosing whatever one you want in your calculator. Please go ahead and type that in. And to 3 places, did you get 2.789? I decided to go common log of 89 divided by common log of 5. But either way, you'll get the answer. Okay, please try this last one here. Did you get 1.172? Again, doesn't matter what base you changed it to, you'll get the same thing. Okay, let's keep going here. Domain of logs. I think I'm going to have to hit pause here because class is about to start and I'm going to have to finish this video later. I'll be back. Okay, let's investigate the domain of logarithms. Remember, we cannot take logs of 2 things, negatives or 0. Okay, so that means that the log of, whatever's in the log, must be greater than 0. Not equal to 0 and not less than 0. So when it says find the domain of the log, what you're going to do is you're going to focus right here on the of. You're going to take that expression, you're going to write it down, and the x plus 3 quantity must be greater than 0. So that means for this first example, x must be greater than a negative 3. Those kinds of x's will be allowed to go in. If you put negative 3 in, that would be log of 0. That's why you have to be more than negative 3, like negative 2.5 and on. All right, let's look at this next one here. Natural log of x minus 7. So you isolate the of. I know it says plus 4, but that's not in the of, so who cares about that? That's just there to be fancy. The of, the thing that's being taken the natural log of, must be greater than 0. So x must be greater than 7. That's all you do. You look at the ofs. Okay, this next one's interesting because I have an of right here, but he's got absolute values on him. So can you put negative into this problem? Yeah, because they'll be taken care of and turned positive. So actually, I can use all real numbers on this one. Well, except the only number that won't work, x cannot equal, that's right, 0. But negatives for this one will be okay because they get turned positive. All right, for part D, I've got a fancy of right here. I've got a rational expression. 1 plus x divided by 1 minus x. That fraction must be greater than 0. How do we solve a rational inequality? You can't just multiply both sides by something because then the sign might have to flip. I taught you this last chapter. Remember how you have to use a number line? That's right. First of all, do we have a 0? Okay, we're good. Everything's on one side. I'm going to put negative 1 and positive 1 on the number line. How about positive 1? Should that bubble be open or closed? Since it's from the denominator, we'll leave it open. What about negative 1? Should that bubble be open or closed? Well, it depends on your sign. Since this is greater, I'll leave it open. So the numerators depends on the sign, and the denominator you never fill in. Okay, it's time for you to test the section. So why don't you take negative 5 and test it and tell me if it's positive. No, doesn't work? Okay, let's go to the next section. Why don't you take 0 and plug it in? And we want positive. Tell me if it's good. It is? Okay, well then let's go ahead and fill that section in. Let's test 5. Does 5 come out positive? It doesn't. Well, then we don't want that. So we're going to go down and write our official answer here. If I do inequality notation, it would be negative 1 less than x less than 1. Okay, or you could use interval notation from parentheses negative 1 to 1. Either way is good. I'll take either answer. If it's the final exam, the answer will be written one way, and you'll have to decide which one it is. I'm not going to write two kinds and try to trick you. All right, this last one has a fancy of. Here is a quadratic. A quadratic inequality, this expression must be greater than 0. Now, we did learn this in Chapter 3. Maybe what we could do here is factor this. Two numbers that make a 22. Well, 11 times a 2 does. One of them needs to be negative and the 9, so we'll make the bigger one negative and positive. There's a couple ways you can do this. I think I'll do a number line technique again. Negative 2, positive 11. Since it's greater, they're both going to be open bubbles. Why don't you go ahead and test negative 5. We want positive. It is? Okay, good. That's good. Negative 5 is a good section. How about 0? 0 comes out negative. That's no good. How about 100? Positive. That's a good section. So the answer for this one, the answer is going to be from negative infinity to negative 2. Union. 11 to infinity. So remember some of the techniques that we learned when solving inequalities, such as squared powers or rational expressions. You have to use number lines to test the sections. Okay, great. See you tomorrow.